Hi there. This video is an exam paper walkthrough of the AQA GCSE Mathematics Higher Tier Paper 2 from summer 2023. This paper is worth 80 marks in total, and this is the second video of 4. It will focus on questions 9 to 14, which account for 22 of these marks. AQA Paper 2s are calculator papers, so a calculator should be used. A little disclaimer, there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 9. A has coordinate 1, 3 and B 2, 9. These are points on a centimetre grid. They're marked there for us. ABCD is a parallelogram. AD and BC are horizontal and each has a length of 5 centimetres. The diagonals of ABCD cross at E. Work out the two possible pairs of coordinates for E. So for this one, we want to be drawing ourselves that parallelogram that's formed by A, B, C and D. Now what it tells us is AD and BC are horizontal and their length 5 centimetres. So let's imagine that the point D is to the left of A. So we've got 1, 2, 3, 4, 5. So we're going to imagine that point D is here. And then point C would be 5 to the left of B. 1, 2, 3, 4, 5. So that's point C. And then E is where the diagonals intersect. So this would be one option for E. So let's read that coordinate off first. So it's -1, 6. However, C and D could also lie to the right-hand side of A and B. So let's do the opposite on the other side. So C will be 5 to the right. 1, 2, 3, 4, 5. So that would be C. D would be 5 to the right. 1, 2, 3, 4, 5. So then we would have a parallelogram here. And then if we draw the diagonals, it gives us another possible coordinate for E. So that's 4, 6. Question 10. Write down the translation vector that maps shape A onto shape B. So the translation vector is just a column vector. So we're going to have these tall brackets that tells us how many places shape A has moved to the left or right and up or down. So we're just going to pick one corresponding corner. So this corner of A corresponds to the corner of B. We're mapping shape A onto shape B, so we're starting at shape A. That's important when we're finding vectors for translations. So we're just going to see how far we've travelled, and we only go to the point where these two lines intersect. So we've gone 1, 2, 3, 4 to the right, and then 1, 2, 3 down. So to fill out this vector, 4 to the right, the top part of the vector is left or right, and it's positive if we go right. Then we've gone 3 down. The bottom part of the vector is up and down, and it's negative when we go down. Question 11. We've been given the formula for the volume of a sphere. A bowl is a hemisphere with radius 12 centimetres, so a hemisphere is half of a sphere. So let's put that there to remind ourselves. Water is poured into the bowl at a rate of 325 centimetres cubed per second for 8 seconds. Does the water fill more than 70% of the bowl? You must show you're working out. So first of all, let's find out how much water this bowl could hold. So we're going to find the volume of this hemisphere. So we're going to use the volume of a sphere, but then because a hemisphere is half of a sphere, we will divide our answer by 2. So let's substitute in what we know. We're given the radius as 12, so we've got 4/3 times pi times r, the radius of 12 cubed. And then once we've got that, we'll divide our answer by 2. So let's stick that into our calculator. 4/3 times I lost my pi button then, times pi times 12 cubed, and then we're going to divide it by 2. So we have 1152 pi. I'm going to leave it in terms of pi in exact form because I don't want to mess around with a load of decimals at this point. This just makes my life a lot easier. So that is the total the bowl can hold. Okay, and we're in centimetres cubed. If water's poured into the bowl at a rate of 325 centimetres cubed per second for 8 seconds, let's find out how much water's been poured in. So 325 times 8. So 2,600 centimetres cubed of water is going into the bowl. So now we're going to find out if that's more than 70%. So the total amount of water that the bowl can hold is 1,152 pi. The actual amount that's going into the bowl is 2,600 centimetres squared. And if we multiply that by 100, that will give us a percentage. So, see, that was why it was miles easier to not write that as a decimal at that point. And then times it by 100. So we have 71.84%. Let's go back to the question. Does the water fill more than 70% of the bowl? 71.84 is greater than 70%. So let's put nice and clearly, yes. Question 12. Show that these two rectangles are similar. So we've got this rectangle that's smaller with a length of 12 and a width of 5. This rectangle that's bigger with a width of 8 and a length of 19.2. So for shapes to be similar, they have to have a common scale factor. And that scale factor has to be the same for all of the sides of the shape. So let's find the scale factor that links the sides of these shapes that correspond. So we're going to find the scale factor for the two widths to start off with. So we're going to do 8 divided by 5. Which is 1.6. So that's the scale factor for the width. So let's find the length scale factor. So we're doing 19.2 divided by 12. That's 1.6. So 1.6 and 1.6, they have the same scale factor, so they are similar. So let's just play it safe. Same scale factor means similar. We've shown it, but it's worthwhile just making a little statement to make it nice and clear. Question 13. A factory packs X boxes of tea bags per hour. Each box contains 80 tea bags. Show that the factory packs 4x over 3 tea bags per minute. Okay, so X boxes in an hour and each box contains 80 tea bags. So 80x will tell us the number of tea bags in total for 1 hour. We're dealing with minutes here though. So 80x would give us 60 minutes. Again, a proportion table just to organise myself. So there's 80x tea bags in 60 minutes. We want 1 minute. So we're going to divide by 60. So we've got 80x over 60 at this point. So this gives us the number of tea bags per minute. So let's simplify this expression. So we've got 80x over 60, which is 8x over 6. Now a little trick here. If you put 8 over 6 as a fraction in your calculator, it will simplify it for you, which is 4 over 3. And obviously we've still got the x there. So we've shown that they pack 4x over 3 tea bags every minute. Question 14. A company has 123 employees. Information about their hourly rates of pay is shown in the table here. The owner of the company uses the data to make two statements. Statement A. Over 30% of employees have an hourly rate that is more than £17. Statement B. The average hourly rate of pay is more than £20. 14A. Show working that supports statement A. So we're looking at employees that have an hourly rate of more than £17. So £17 is going to fall within this range between 14 and 20. Now 17 is the midpoint between 14 and 20. So we can assume at this stage that half of these earn £17 or more, and then this 15 and this 10 also. So 16 plus 15 plus 10 is 41 people in total potentially earning £17 or more. Let's see how that compares to 30%. So we've got 41 out of 123 in total, and then if we multiply it by 100, that will give us our percentage. So 41 out of 123. So that's 33.3 recurring percent. So we've shown working out that supports statement A, saying that over 30% of employees have an hourly rate that's more than £17. 14B. Why might statement A not be true? Well, it might not be true because yes, 17 is the midpoint between 14 and 20. However, we don't know what the distribution of wages is within those 32 people. So what we have to say there is we don't know the distribution within the interval, and that's the 14 to 20 interval. So it's as simple as that. We assumed that with it being the midpoint, it was half, but we don't know that exactly because we don't have all of the data. Okay, work out an estimate of the mean to support statement B. So we're going to have to go back to our table here and use this information too. So to find an estimate of the mean, we need the midpoints of all of these ranges to start off with. So the midpoint of 10 to 14 is 12, 20 to 30 is 30, 40 to 100 is 70. If you're not sure, 40 plus 100, 140 divided by 2 is 70. And then what we're going to do is we're going to times these values by the number of employees. So we're going to have 12 times 66, 17 times 32. We can do this because it's an estimate. 30 times 15 and then 70 times 10. So let's do that to start off with. 12 times 66. 17 times 32. 30 times 15. And then 70 times 10. So let's find the total of those. So 792 plus 544 plus 450 plus 700 is 2,486. Now we're going to divide that by the total number of people, which we know is 123. So that tells us it's 20.21. Okay, so let's remind ourselves of statement B. The average hourly rate of pay is more than £20. We've just worked out that the average hourly rate of pay is £20.21. £20.21 is more than £20. Okay, 14D. Why is the mean not the best average to represent the data? So this is simply because it can be affected by outlier or extreme data values. So it can be affected by outliers, extremes. Okay, because it includes all of the data, doesn't it? We can't see it visibly.